Hello and welcome to Graphing Quadratics. Today we're going to learn how to graph an equation if it's a parabola and if it's in factored form, which we'll talk about later. So we're looking at something like this, and the directions are to find the intercepts and the max and min to graph the function. So the first thing we want to think about are the x-intercepts. We want to make sure that we are setting the function equal to 0. We're going to say, let's let this be 0. And then think about what would be the things that x could be, the values for x that would make the function equal to 0. We know from the zero product property that if two things are multiplied together to equal 0, one or the other has to be 0. So either x plus 2 has to be 0, or x minus 4 has to be 0. If x plus 2 is 0, then x is negative 2. If x minus 4 is 0, then x is positive 4. So when the value of the function is 0, when the height is 0, the x-intercepts are negative 2 and positive 4. 1, 2, 3, 4. Okay, and we can represent that when we say x-intercepts, we would write it negative 2, 0 and 4, 0. That's how we would express those things. Okay, next let's find the max or the min. The thing about parabolas is that they are symmetric. So they are equal on one side as they are on the other, and the max or the min is going to be right down the middle. So one of the things we can do is find where's the middle of these 2 points. Where's the average of those x-intercepts? Because that would find us the center of the graph, which would tell us where at least the x part of the max or min is. So if I think about what's the average between negative 2 and positive 4, the middle of that looks like it's positive 1. That would be 3 steps this way and 3 steps this way. So we can draw an imaginary line kind of straight down here at x equals 1, and that we would call the axis of symmetry. That is the middle of the graph. And I know that for my vertex, the max and the min are called vertex, but the vertex would have to lie on that line someplace. So the x part of that is 1. Now I don't know how high or how low. It could be anywhere up here or anywhere down here. It could be a max or it could be a min. So what I need to do is actually plug 1 back into the function and see what's the height of the function when x is 1. So if I plug in f of 1, that would give me 1 plus 2 and 1 minus 4. 1 plus 2 is 3. 3 times negative 3. And this is negative 9. So f of 1 is negative 9, which means when x is 1, y is negative 9. So I can come down here to negative 9, and there is my minimum. I can also find the y-intercept now by letting x be 0. We can find f of 0 by plugging in 0. 0 plus 2 and 0 minus 4. So that is 2 times negative 4, which is negative 8. So when x is 0, the y-intercept is the point when x is 0, y is negative 8. That is right here. And so we can draw our graph. It's going to look like this. It's going to do the same thing on that side as well, because it's symmetric, and it's going to go right through here and right through here. Okay. Now you see this first number in this equation, we're not really writing, but what number is really there, this leading coefficient is really the number 1. And that's helpful to us because if it's positive, it's going to open up. And the number 1 is actually kind of a special number. This is the general shape of a parabola if this number is 1. As this number gets higher, like 2 or 3 or 4, it gets skinnier and skinnier and skinnier. If it's like 1/2 or 1/3, it gets fatter. So this number tells us both the direction, does it open up or open down, and it tells us if it's fat or skinny. Okay, so this one we can look at and say, aha, the number on this one, the leading coefficient is negative 3, which means it's going to open down and it's going to be pretty skinny. But the first thing we can do is find the x-intercepts. Let's let this be 0 and say the negative 3x, x plus 4. Here's 2 things multiplied together to equal 0. So one or the other has to be 0. So x has to be 0 here, or x has to be -4 here. So my x-intercepts are 0, 0, and -4, 0 here, and 1, 2, 3, 4. Now the middle between 0 and -4 would tell me where my max or min is. The middle of that is -2. So the axis of symmetry is the line x equals -2, and we know that's where the maximum or minimum is. So let's plug that in. We know the vertex is going to be -2 something. Let's plug in -2 into our equation for x and see what that something is. -3 times -2 times -2 plus 4, and that gives us, this is 6, and this is 2, so 6 times 2 is 12. Okay, so f of -2 is 12. That tells me the vertex is going to be a maximum way up here at 12, 11, 12. And like I told you, it's going to open down and it's going to be very skinny. And it looks that way. In this one, the y-intercept is also 0, because we can see it right there. The y-intercept is 0, 0. It's an x-intercept and a y-intercept in this problem. So it's going to have a maximum up here. It's going to be very, very skinny. And come down like so. Something like this. It's not very straight, but oh well. Okay. This one we have a fraction. What does that tell us about the graph? It means it's going to be a little bit fatter. It's not going to be skinny. And it's positive, so it will open up. We should expect a fat fraction, fat parabola that's opening up. Okay, let's first let it equal to 0. 0 equals 1/2 x minus 1 x plus 3. Now the 1/2 here doesn't really affect anything here. We could divide by 1/2 or multiply by 2 and get the same thing. So that doesn't really affect anything. But now we have zero product property that 0 equals the first thing or 0 equals the second thing. So x could be 1 or x could be -3. So we would say 1, 0, -3, 0. Those are my x-intercepts. And that's going to be here. And 1, 2, 3. Now where is the middle in between +1 and -3? That looks to be -1. So there's my axis of symmetry. So I know my vertex is -1 something. And since it's positive, it's probably going to be down here, and it's going to be fat. So it's probably going to be right up in here someplace. But I can plug it in. So f of 1/2 equals, no, not 1/2, not 1/2, f of -1. Here comes my 1/2. 1/2 times x minus 1 times x plus 3. Oh, but I'm putting in -1 right there. Forgot to write that. Which is 1/2 -2 + 2. 1/2 times -2 is -1. And -1 times 2 is -2. So f of -1 is -2. That is my minimum right here at -2. We knew it was going to be pretty high up there, so that it's a fat parabola. It's a little bit fatter than some of our other ones. Oh, I forgot to find the y-intercept. I just need to let f be, or x be 0 and plug that in. 1/2, 0 minus 1, 0 plus 3. So that is -1 here. That is 3 here. That is 1/2 times -3, which is -1.5. And it looks like, so it was maybe right about there. Should have been a little bit fatter than what I drew. Okay, your turn. Pause the video, try this problem, and then I'll show you. Pause it, try. Okay, let's go through it together. We let this be 0, 2x, x minus 6. Here's zero product property, so either 2x equals 0 or x minus 6 equals 0. So x could be 0 here. So my x-intercepts are 0, 0. Hey, that'll be the y-intercept too. And 6, 0. So we've got this, and 1, 2, 3, 4, 5, 6. Where's the middle between 0 and 6? That is 3, right here. 1, 2, 3. Okay, so we know the vertex is going to be 3 something, and we can plug in that 3. Find f of 3. And it's negative, so 2 times 3 times 3 minus 6. 2 times 3 is 6. 3 minus 6 is negative 3. Oh, negative 18. Did we think it was going to be down low? Maybe. What was that first term? Way down here, 3, negative 18. Well, we knew it was going to open up, and we knew it was going to be skinny. So it makes sense to be, here's 10, so maybe 18 is down here someplace. We know it's going to be skinny. We know it's going to do something like this. Coming up and coming up. So if you got that and you went off the graph and you second guessed yourself, I guess you are all right. All right, I hope this is helpful for you to learn how to graph parabolas if they're in factored form. Have a great day.